In this video, we're going to talk about the quadratic formula. So far, we have learned three methods to solve equations. Factoring is an efficient way, but doesn't solve every equation. The square root property is limited to equations of the form x squared is equal to k, where k is any real number. Completing the square does solve every quadratic equation, but can be very tedious, especially if the leading coefficient is not 1, and the coefficient of the linear term is odd. So I want to solve the equation for x by completing the square for this. So we want to divide each side by a because we want the leading coefficient to be a 1. So we simplify here. I'm going to subtract the CA over. And now I'm going to complete the square. So with this, I'm going to take what? Half b divided by a, which is b over 2a. And when I square that, I get b squared on the top. And 2a times 2a is 4a squared. So add that to both sides. And now I can factor. Remember, I can factor this by using the very first part of completing the square. So that's x plus b divided by 2a squared. Okay? And I'm taking negative ca plus b squared divided by 4a squared. Well, that work is shown here to get the b squared minus 4ac divided by 4a squared. Take the square root of both sides. Rewrite them as two separate radicals. The square root of 4a squared is 2a. And because now the denominators are the same, I can rewrite that as one fraction. So what did we just derive out of all of this? We just derived what is called the quadratic formula. The quadratic formula, given the equation ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the value under the radical in the quadratic formula. In other words, it's b squared minus 4ac. The discriminant determines the number of unique solutions and the type of solutions each quadratic equation has. So let's solve the following equations using the quadratic formula. For the first example, notice the equation is set equal to 0. So now I need to be able to determine what a, b, and c are. Well, a is 1, b is 7, and c is 8. Writing the quadratic formula, now I'm going to substitute the values in for a, b, and c. All right, let's simplify under the radical. Simplify one more time. So I have two solutions here. Negative 7 plus the square root of 17 divided by 2, and negative 7 minus the square root of 17 all over 2. So the discriminant is 17. So, because I don't know the square root of 17 without a calculator, I have two irrational solutions. And that's telling me I was not able to factor this equation to begin with. All right, let's go to the next example then. It's already set equal to 0, so now let's determine what a, b, and c are. So a is 25, b is negative 20, c is 4. Now let's write out the quadratic formula. Now I want to substitute the values in for a, b, and c. Now I want to simplify under the radical. So notice I have 400 minus 400, well that's 0. Now 20 plus the square root of 0 is the same thing as 20 minus the square root of 0. So x is equal to 20 over 50, which equals 2/5. So the discriminant is 0. And I have one rational solution. Because again, I know what the square root of 0 is quickly. And because I have a rational solution, I know this is factorable. So this can be broken down as 5x minus 2 times 5x minus 2. Okay, so let's go to the next example. Now, I need to set this equation equal to 0. So I'm going to add 3 to both sides. Now that it's set equal to 0, we know A is 2, B is 1, and C is 3. So now what I want to do is I want to write the quadratic formula out, and I want to substitute in for A, B, and C. So now I've done that, let's simplify. And we know 1 minus 24 is negative 23. Now, there's no perfect roots I can pull out, but I know I can pull an I out. Again, don't forget to put the I outside the square root. So in this case, the discriminant is negative 23. And because it's negative, I know I have two complex, non-real solutions. One more example I want to take a look at. So first thing I want to do, I want to set this equation equal to 0. Now, you can put any numbers you like into the quadratic formula, but I would prefer not to put in fractions, as I'm guessing you would not like to put them in either. So I'm going to multiply every single term by the LCD, which in this case is 2. 2 times a half, that's 1, so that's x squared. 2 times negative x is negative 2x, and negative 2 times 2 is a negative 4. So now we know A is 1, B is negative 2, C is negative 4. So I'm going to write out the quadratic formula and substitute in for A, B, and C. Okay, so let's simplify. Now, I can pull out perfect roots of the square root of 20. The square root of 20 is the same thing as 2 times the square root of 5. Now, notice every single term has a factor of 2 I can divide out. So this is the same thing as 1 plus or minus the square root of 5. So the discriminant is 20. And again, I don't know the square root of 20 off the top of my head, so I know I have 2 irrational solutions. And again, because I have irrational solutions, that is telling me that this equation is not factorable.